Hey guys, so in section 13.3, this is a section from the chapter 13, which is about probability and statistics. We don't need to do a whole section on that, or a whole chapter on that, because you guys know the simple probability stuff, and some of it we just don't need to really worry about. But we do need to worry about this geometric probability. It fits in perfectly here, because what we're going to do is we're going to take probability, the theory of probability, and we're going to place it into space, into geometry, basically using area is what we're going to do. So that's why it fits in perfectly with this, because this is the area chapter. So what we're going to do is we're going to first find probability with length. Alright, this one is pretty straightforward, it's pretty easy to work with. Alright, basically the idea here is if I want you to basically have like a string, imagine that RS is a string. Okay, you've got this whole length. Right, and I ask you to close your eyes and randomly with scissors just cut somewhere along that string. Okay, and I made some marks and said, well, what are the chances that that cut, if it's completely random, ends up between K and L? Okay, what you're going to do for that probability is you're going to take the length of KL and you're going to divide it by the length of the whole thing, which is RS. Okay, so very, very simple. You're literally just counting, in this case, maybe a little bit of addition, subtraction, but that's about it. Okay, so you can look at their example, and here's a couple examples for us. Okay, so point M is chosen at random on ZP, right? That's similar to, you cut randomly along that string, right? ZP, we need to know this whole length because we're going to be using that the whole time. So 2 plus 3 plus 5 is 10. Alright, so what are the probability, what's the probability, what are the chances that M, that random point, is on ZQ? Okay, so you look at the length of ZQ, it's 2, divide that by 10, we get 2 divided by 10, which reduces to 1/5. Oops. Okay, we're going to give all these answers as fractions, but you can also give it as a decimal, 0.2 is the probability, or you could give it as a percentage, 20% as the probability. Okay, so all those are options. We're going to do fractions. I'll tell you if I want fractions, decimals, or percent in each of these cases. Okay, and number 2, what's the probability that M is on QR? So you look at the length of QR, it's 3. The answer is 3 over 10. Hopefully this is clicking with you. It's pretty easy. Alright, what's the probability that M is on RP? 5 out of 10, which reduces to 1/2. This length right here. Alright, the last one you have to do a little bit of addition, but nothing too crazy. What is the probability that M is on QP? Alright, so I start at Q, go all the way to P, that's 8, so it's 8 over 10, which reduces to 4/5. Okay, that's all you need to be able to do. You don't need to really worry about these two word problems, okay? Wouldn't give you something like that, so we can move on from there. We're just getting the simple basic probability. Okay, the back page, the second page, is the part where it gets a little bit more difficult, because that was just one dimension. Right, we were just working with length, so you could just literally count. Right, when we start working with 2 dimensions, now you're going to start finding areas. Okay, so if we take a look at, we're just going to use this example down here to explain how to find the probability. We're trying to find the probability that you land in the center of this, right, like the bullseye section. Okay, so if I want to find the probability of that you land in the shaded region, all right, what you're going to do is you're going to find the area of the shaded region, and you're going to divide that area by the area of the whole thing, the total possible places where you could land. Okay, so you're going to have to be finding a lot of areas, but we can do it, I promise. Right? Now, I'm going to give you very straightforward just shapes, but so for these 2 word problems, what I'll do is I'll draw it out for you, and then we can work through it together. Alright, so you've got a rectangular field. Rectangular field is 120 by 30. And in there's a circular target. Right, and that circular target has a radius of 10. Okay, what's the probability that you land inside the target? Okay, so I'm trying to land in the circle. Okay, so obviously what I need to do is I need to find, for the probability, it's the area of the shaded region, which in this case is just a circle, which is really nice and easy for us, divided by the area of the whole thing, which is really easy as well. It's a rectangle. Okay, so I'm going to find the area of the circle and divide that by the area of the rectangle. Okay, so that area of the circle is pi r squared, where the radius is 10. So that's 100 pi. And the area of the rectangle is 30 times 120, which is 3600. base times height. Okay, for something big like that, you could definitely reduce that if you wanted, right? But because there's a pi in there, the fraction just isn't going to make a whole lot of sense. So what I suggest in a case like this is multiply it out and let's get a decimal. So 100 times pi divided by 3600, and I get 0.09, which is the same as 9%. So there's a 9% chance that you land inside that circle target. Okay, and the second one. Alright, we've got a clock. Alright, this one's kind of easy. A lot easier than you'd think, right? So you've got this clock, obviously a circle. What's the probability that your second hand is between the 2 and the 3 hour numbers? Okay, 2 hour, 3 hour, something like that. Okay, so if you want that probability when we're in there, right, you have to think about just, obviously it's moving around the circle at a constant speed. So if you think about how often it's in there, well, how often it's in between any two numbers is 1/12, right? Because there's 12 possible sections. So the chances you're between 2 and 3 is just going to be 1 out of 12. Okay, and the reason for that is because there's 12 equal sections and it's got constant speed. Right? Alright, now numbers 3, 4, and 5 are the ones that you're most likely going to see. You'll for sure see 2 of these on your homework check, and then you'll see one that's like this pointer problem at the bottom, right, that I'll go through in a minute. But what we need to do is start finding the probability that a point is in a shaded region. Okay, so number 3 is one where you might get confused because there's no lengths on there, right? There's no way to actually calculate the area. But I put that one on here because I wanted you to look at those, because usually there's a pattern or something you can do where you can kind of just count things up in that case. Right? So the reason for that is because if you look at all these triangles, all those triangles are congruent to each other. Right? They're all the same distance. So we've got 1, 2, 3, 4, 5, 6 of those. So the probability of the shaded region, or the area of the shaded region is going to be 6. Okay, in the total area, the white ones are also congruent to that, so we've got 7, 8, 9 total. So it's just 6 over 9, which reduces to 2 over 3. Okay, and if you just wanted to use 0.67 or 67%, that would work as well. Alright, and number 4, this is where we have to do some calculation. Okay, so for this calculation, we've got, what I need to find is I need to find the area of the square divided by the area of, the area of the shaded region isn't the area of the square. The area of the shaded region is the area of the circle minus the area of the square. Okay, to get that shaded region, you find the area of the circle, subtract off the area of the square, and the total area is just that area of the circle. Okay, so I need 2 things. I need the area of the circle, and I need the area of the square. Right, the area of the square is really easy. We've got base is 2, height is 2, so the area of that square is going to be 4. Okay, 2 times 2 is 4. Now I've got a triangle in there. Hopefully you guys know how to solve that triangle, but I'll tell you, you need to find the hypotenuse of that, because the hypotenuse of that is going to be the diagonal of the circle, which is going to help us find the radius of the circle, which is going to help us find the area of the circle. So if you use Pythagorean theorem, you could do that. You're going to get 4 plus 4 is 8, and square root of 8 is 2 root 2, or you could just notice that this is a 45, 45, 90 triangle. So you're going to get 2, 2, and 2 root 2 as your diameter. Okay? So if the diameter is 2 root 2, the radius of that circle is going to be just a 1 root 2. So it's going to be pi times root 2 squared. Okay? Root 2 squared is just 2, and multiply that by pi, and we get the area of that circle is 2 pi. So I can get rid of both of these and change them to 2 pi. And now I can just make that calculation. Okay. So once again, this doesn't really make sense as a fraction because you can't really reduce that or simplify it. You can't just cancel those pi's because you're subtracting the 4 from the pi in the top, so you can't just get rid of the pi's. Alright, so what you need to do is type it in the calculator. I'll do that right now. 2 times pi minus 4 divided by 2 times pi. We get 0.36, or 36%. Okay, obviously make sure you could take a look at these things and guess what you're supposed to be, and that might help you make sure you didn't make any mistakes. Okay, number 5. For number 5, we need to find the shaded region, which is just a square, divided by the total area, which I'm looking at as a trapezoid. But if you didn't want to do that, if you wanted to deal with that as just a square plus a triangle, I'm fine with that as well. However you find that total area works for me. Okay, now I said that that shaded area was a square, right? The reason I know that is because I've got a 3, 4, 5 triangle here. Okay, so I used Pythagorean theorem to work backwards. 5 squared minus 3 squared is 16, and square root of that is 4. So I know the height here is 4. And the top has to be 4, so I see that the whole thing, right, is all 4, so it's got to be a square. So the area of that is 16. Okay. Now I have to find the area of that trapezoid. Okay, to find the area of the trapezoid, you have to remember what the equation for it is. All right, it's base 1, 4, plus base 2, this bottom part that I traced, which is 3 plus 4 plus 3, which is 10. 4 plus 10 divided by 2. The average of the bases times the height, which is a 4. Okay, so I need to multiply all that stuff out. Top's still going to be 16. The bottom I've got 4 plus 10 divided by 2 is 7, and 7 times 4 is 28. 16 divided by 28 can reduce to 4/7. That one does make sense as a reduced fraction, so we leave it like that. Okay, you need to practice those problems. Those are the toughest ones. Okay, now the last thing that we're going to do is just work with these probability with a spinner. Okay, so this is just going to all be over 360, right? I just give you the degrees, how wide the section is, and you're going to find the probability. Okay, so what's the probability that the pointer lands on red? All right, so if that's the case, I'm going to look at the red. Red's 40 degrees. It's 40 over 360, which reduces to 1 over 9. Okay, what's the probability that you land on blue? Find the blue section. It's 30. You're going to get 30 over 360 reduces to 1 over 12. Okay, what's the probability that we land on green? Look at the green section. It's 80, so it's 80 over 360. Reduce that, and that reduces to 2 over 9. Okay, that's all we're doing in this chapter. So check this out. Get ready for the homework check next class.